New dinosaur discovery. The scimitar-crested Spinosaurus reopens the biggest fight in prehistoric science. This new dinosaur discovery is headlined by a blade-like crest from the Sahara, but the true story lies in how fragmentary fossils, habitat bias, and diagnostic limits could reshape our understanding of Spinosaurus. A new Spinosaurus species has been announced from fossils found in Niger's Sahara, with a tall, curved skull crest that researchers describe as scimitar-shaped. But the real story is not just the crest. It is how far careful anatomy can take you before the fossil record's gaps force you into judgment calls, and how those calls can flip when the next few bones show up. The story turns on whether the fossils capture a truly distinct species signal or a thin slice of variation from an animal we still do not know end to end. Key points. Researchers describe a new Spinosaurus species, Spinosaurus mirabilis, based on fossils from Niger, highlighted by a distinctive, curved cranial crest. The evidence strongly supports some claims: a large crest, fish-eating jaw adaptations, inland river deposits, and weakly supports others: exact lifestyle, swimming ability, full body proportions. The find contributes to an ongoing debate about whether Spinosaurus was primarily a wader, a swimmer, or an opportunist that adapted to conditions. A key constraint is that Spinosaurus is famously incomplete and often reconstructed from partial remains that may not come from a single individual. Sampling bias, where fossils are easiest to find, can shape the story as much as the animal's real biology. The fastest path to confirmation or falsification is a more complete, single-individual skeleton that includes limbs, pelvis, and tail in clear geological context. Spinosaurus is a large, fish-eating theropod dinosaur from late Cretaceous North Africa, famous for a long snout, conical teeth, and tall spines along the back that form a sail-like profile. In 2014, a major redescription of Spinosaurus fossils helped ignite a modern argument about how aquatic it really was, and that debate has stayed active because key bones remain rare and unevenly preserved. The new fossils come from an inland Sahara setting in Niger reported as a riverbank or river sediment context, far from what would have been the nearest marine shoreline at the time. A new name meets a hard limit: uniqueness versus variation pressure. A new species claim lives or dies on diagnostic traits, consistent features not easily explained by age, sex, deformation, or individual variation, and not already covered by the known species range. Here the headline trait is the large, curved cranial crest. Multiple crest specimens were reported from the site across different field visits, which strengthens the case that the crest is not a one-off oddity. What it does not automatically prove is how common the crest was across the population, whether it changed dramatically with age, or whether it differed between sexes. Fossils seldom answer those biological questions cleanly, unless growth series, juvenile to adult sequences, and multiple well-preserved individuals are available. The lifestyle fight returns. Heron logic versus crocodile logic, under conflict. Two kinds of claims travel with Spinosaurus, and they are not equal in evidentiary weight. One claim is about diet mechanics, interlocking, interdigitating. Tooth rows and cone-shaped teeth are directly tied to holding slippery prey, and multiple reports emphasize this fish trap function. That is a strong inference, because it is anchored in jaw anatomy, not vibes. The other claim is about locomotion in water, wading versus sustained swimming. The new inland, river-associated context pushes against a simple open water pursuit predator story. But it does not settle how often the animal swam, how fast it could move in water, or whether it used mixed tactics, like ambush from shore, plus short swimming bursts. This is why reasonable experts can look at the same broad picture and still disagree. The debate is partly about anatomy, but partly about what behaviors you allow a huge animal to use when it must eat constantly. The core bottleneck, no single complete individual, is the stability constraint. Spinosaurus reconstructions often stitch together partial remains across time, space, and individuals. That is not scientific sloppiness. It is triage in a fossil record that preserves skull bits here, vertebrae there, and crucial limb elements only occasionally. Because of that, whole animal statements, exact proportions, exact limb length, exact swimming capability, carry wider uncertainty than this jaw did X assertions. Even when a report mentions comparative differences like snout shape or limb traits, the stability of those comparisons depends on whether the elements truly belong to the same species and fall within adult anatomy rather than growth stages. As a general rule, the closer a claim is to a single preserved structure, the more confident it is. The more the claim requires assembling the animal as a system, the wider the error bars get. The hinge, in plain terms, the Sahara preserves some things and erases others. The underappreciated mechanism is not a flashy bone. The fossil record serves as a filter. The Niger discovery is partly powerful because it expands where Spinosaurus is documented, adding an inland setting to a record often associated with near-coastal deposits. The geographic shift matters because it changes which habitats are in the evidentiary sample. But sampling is never neutral. Field access, exposed rock, and what erosion reveals can shape which parts of an ecosystem you see. If coastal deposits are easier to survey or more frequently exposed, you will overlearn coastal stories. If an inland site suddenly yields spectacular skull material, you will overweight whatever skull traits that site preserves best. Therefore, the correct mental model is not that the fossil record provides us with the truth. It is said that the fossil record gives us biased snapshots, and the bias itself can masquerade as biology. Measurable tests, the signal that would confirm, and the signal that would break the story. Confirmation is not about a prettier illustration. It is about reducing ambiguity in 3 places. First, a single individual skeleton that includes skull, spine, pelvis, limbs, and tail in consistent context would tighten both species diagnosis and lifestyle inference at the same time. Second, juvenile material would test whether the crest is a late-life display structure, an all-life identity marker, or something that scales unpredictably with growth. That matters for whether crest size is truly diagnostic at the species level. Third, finding more evidence that links habitat clues to the same animals, like clear soil types, related animals, and consistent patterns in different locations, would help researchers distinguish between where this fossil was found and where the animal actually liked to live. What most coverage misses, the hinge, is that the biggest swing factor here is not the crest, but the sampling filter that decides which Spinosaurus stories are even visible. The issue is that when discoveries happen in specific types of locations, like coastal areas, riverbeds, or inland sites, researchers might end up discussing the environment based on data influenced more by the wood type of rock and how easy it is to access than that. Changes timelines because the next field season in a different deposit type can reweight the evidence and force confident narratives back into the maybe pile. Signposts. Watch for 1. Reports of more complete individuals from Niger that keep skull, limbs, and tail together, and 2. New analyses from other teams that test aquatic versus wading behavior using independent signals rather than the same small set of bones. What happens next? In the short term, the next 24 to 72 hours of coverage will mostly recycle the same claims: new species, sword-like crest, and hell heron imagery. The science question is narrower: which traits are truly diagnostic, and which are interpretive scaffolding? In the upcoming weeks and months, the focus will be on maintaining stability. The species diagnosis should become more robust if other researchers can examine the material, compare it against known variation, and see the same trait pattern repeat. That matters because taxonomy is the filing system for everything that follows, from ecology to evolution. Longer term, the debate will move only if new bones arrive that directly constrain locomotion, because behavior claims live downstream of anatomy. The main consequence is that the public narrative surrounding Spinosaurus will continue to outpace its preserved skeleton, making it a dynamic subject. Real-world impact. Museum teams and science communicators will get a fresh, high-confidence visual hook, the crest, that helps explain how paleontologists diagnose species from fragments rather than from full skeletons. Field programs and funders may treat this as validation that remote inland Sahara work can still deliver top-tier results, which can shift resources toward harder-to-reach localities and longer expeditions. Teachers and parents will see a useful lesson in uncertainty. One discovery can be real and important while still leaving big questions open. That is how evidence-based science actually behaves. Content platforms will amplify the new species hook, but the more durable public value is the distinction between what bones show and what stories we project onto them. The next constraint: to watch. The fascination with Spinosaurus will keep producing confident cartoons of behavior, and that is fine as art. The science lives in the constraint. Fragmentary fossils force wide uncertainty bands, and those bands are not a weakness, they are the honest shape of the data. If the next major find is a truly complete individual, the field will get a rare chance to reconcile competing models instead of trading intuitions. If it is another isolated cluster of dramatic skull pieces, the debate will sharpen, but it will not settle. Either way, the signposts are concrete: more connected bones, clearer context, and independent tests that can break cherished narratives as easily as they confirm them. The historical significance of this moment is that it adds a second named Spinosaurus species while putting the limits of the fossil filter back in the spotlight.